Hello again, everybody. Discussing about relays yesterday. Let's say you have a no start problem. Absolutely nothing starts on your car. Now, when it comes to these type of situations, and you pull the schematic out, where's the first point that you look at out of all these symbols? Since I'm dealing with a problem with the starter, I'm going to go look at a starter. That's the first place I'm going to look. This is the symbol for starter. These are the solenoids, the windings that pull in this contact. This contact is out here. Once these are activated with current flowing through them, this switch is closed and you have current flowing to the starter motor. So how does it get energized? In order to do that, we have to go back. Okay, here's a relay. This is a relay. Before that, to a fuse. And before that, a junction where you have a connector. And then going back to the battery. So let's start this again. We know this symbol gives us the starter motor. We backtracked it. Since we know that path, when we backtracked it, let's go forward now. This is how I analyze schematics. Here's the battery. 6 cells in it. As you can see, 6 cells. This one goes to the engine block. It doesn't say that here, but it is the negative goes to the engine block. So you always have to make sure that the negative is on secure, tight. If no lights come on, if the door, when you touch the door, when you open the door, if it's power locks, you won't be able to open it. The lights will not go on, obviously. Power locks will not go on. Power unlocks will not go on. Whatever is power will not go on, if the battery is really weak. But now it goes to the engine block, which is the body. Follow this. We go through a fusible link. So in this path we have a fusible link, almost like a fuse, rated at 12 gauge and a white one. Now, point of it is two wires soldered together, and they have a melting point at a specific temperature that makes them melt. Of course, what happens? They break apart. What does that do? That protects this part of the circuit. The solenoids will not be activated and the starter will not be activated. It protects the starter circuit, almost like a fuse. Current flows here, out here on the white wire. See white, it says, through this. Now, how much voltage should we have? We should have 12 volts over here. We go through here, through the other side of the fusible link. How much should we have at the other side? Well, 12 volts. Why? Because this is just a wire. We do not lose any voltage drop from here till here. Now it goes to another connector, through a junction connector. Still a white wire over here. We said we have 12 volts over here. How much do we have on the other side? 12 volts. Why is that? Still, it's just a connector. You don't lose a voltage drop across that. Continuing here. Current flows through here. As you can see, ST, AM2, a starter fuse, rated at 30 amps. Quite high for the solenoids. So we have 12 volts here. How much should we have here? 12 volts. Why? We do not lose any voltage across a fuse. So far, we didn't lose any voltage. We're at 12 volts, just like we started. Come till here. Now, these are the contact of the relay. We know we have 12 volts at this black wire. We started with a white. Now we're getting to a black wire after it goes through the fuse. Pins are, and this, see this little thing over here? Denotes a connector. This is a pin 5. This is a pin 3. In this default symbol, these are not 5 and 3 are not connected. So if you would do a continuity check, meaning an ohmmeter check, these two are not connected. When are they connected? When this has current flowing through it, you get an electromagnetic field. You see these dotted lines? These dotted lines represent that this contact, this switch, will be pulled in, as I have highlighted by the orange line. So when current flows here, now this is closed. You have a connection from 5 to 3. So now current can flow here. How much would we measure here? If we set 12 volts over here, how much should we measure here? 0 or 12? The answer is 12. Why? This is just a switch, a contact. We do not lose any voltage across that. Now we come down here to the solenoids, the relays. As we started off, this is a blue wire, red, and then blue, pin 1, and once this is activated, this pulls in this one, and from here to here is the connection, allowing the current, the full current, to go through. Now, this is rated at 30 amps going to the solenoids. Remember, going to the starter motor, you can pull more than 200 amps. It's about an amp for every cubic inch. So if you have 270 cubic inches of an engine, it's about 240 amps, roughly an estimate. Remember, you can't lose too much of a voltage drop across here also. Maybe about 0.3, 0.4 volts. You can't lose 1 or 2 volts across this wire. Also from ground, you cannot lose 2 or 3 volts from the starter to ground. Otherwise, you'll be left with 8 volts, 7 volts to the starter. So remember, this is a thick wire, but the resistance of it is very, very low to allow the large current to go through. Now, scenario by scenario. We said this is activated. What causes this to be activated? We said a current flowing through this relay. How do we get this relay to be activated? We look at the schematic. We know that two variables cause a relay to activate. A ground and a plus. The plus or the ground can come from a computer, or it could be a physical ground. In this case, the physical ground is here, left front of engine compartment. Fine. That's the 0 volts. Here, that means if this side is 0 volts, that means the other side has to be 12 volts. So pin 1 is ground. Pin 2 has to be the 12 volts. Let's look if that's true. Where does it go to? When I looked at the other page, green wire, which is 2, goes actually to a park neutral switch, and also goes to the computer. So the computer makes sure that you're in the right gear shift, is in the right selection, either park or neutral. Once it detects it is, then it sends a 12 volts and activates this. This then activates the solenoids, and the rest is history. Let's take a scenario where I had a customer one time, no start problem. Says, oh, I'm sure it's the battery, right? Changed the battery even twice. Nope. AutoZone made a good profit off of him. Next, it's the starter. I know it's the starter, okay? Let's prove otherwise. If I want to troubleshoot, we know how it works. Where's my point of attack? Meaning, where do I go to measure the voltage? I analyzed it. I understand the computer has to turn this on. Once this is turned on, this is turned on. Solenoid's activated. Then this current can flow into the starter. And where's the starter connected to? The flywheel. You have on Fords, you have problems with flywheels. Then the flywheel goes to the crankshaft. You need a gear ratio. A starter cannot directly go crank an engine. You need it from this to the flywheel. That's why I said Fords have problems with flywheels, and when the flywheels go, it takes the starter with it. So you'll say, okay, I'll replace the starter. No, always check the flywheel. The ring gear they call it. You have the pinion gear from the starter going into the ring gear of the flywheel, and that goes to the engine, the crankshaft. Anyway, now we know how it works. What's my point of attack? Since we're dealing with the starter of no start, you'll say, okay, you know what I'm going to do? I'm going to go to the starter, measure 12 volts at the starter. I'll say, no, I disagree. Why? Part of troubleshooting in automotive is looking for easy access points. You're not going to go under the bottom of the car, lift up the car, if you're in your driveway, whatever it is, and try to measure 12 volts, or try to jump the solenoid like many people do. Try to jump the solenoid to the starter to see if it comes on. You have to get to that point, and it's not easy to get to that point. The easiest point to get to is the power distribution box, the fuse panel, or sensors, which are under the hood. So it's not just about which is the best point to measure, but it's also which is the most accessible and the most convenient. So which point will I pick? Guess what? If I know the computer turns this on, and then I know this is activated, this is like the input. Think of this as the input, this is the output. Where am I going to go out of these 4 terminals? Guess what? I'm going to go here. I'm going to go to the power distribution board, lift up the fuse cover, look for this relay, ST relay, and I'm going to go try to measure 12 volts here. Why? Why would I say such a thing? Because if the computer gave 12 volts, turn this on, this is 12 volts, this is 0 volts. The whole voltage drop is 12 volts across this. Fine. We established that. What do I do over here? If this is activated, guess what? We just said that this is 5 is connected to 3. So when I come over here and I measure 12 volts, guess what that told me? That told me the computer is doing its job. It gave this relay at 12 volts. It gave this a 12 volts because I have a 12 volts here. That means all the computer is working, the relay is working, the coil, and the contacts are working at one shot. Now you're going to ask yourself, but Joseph, why don't I start at 12 volts? You don't have to. This is the output. Think of this as the output. This is the point of attack right here. If I have 0 volts here, then I would come back up here and say, okay, maybe I lost it through the fuse. Then I'll measure 12 volts up here. If I have 12 volts over here, but 0 volts over here, then I'll say, okay, maybe it's the computer did not give me the 12 volts to turn this on. Remember, regardless if this is turned on or not, this point will always have 12 volts. Because it's just going through a fuse, through a wire. But this will not have 12 volts. Might not have 12 volts, and this might not have 12 volts. If the computer is not working, could be a computer problem. Remember that. How many times have I said it could be a PCM, ECU problem? Not everything is a starter problem in computerized fuel injection cars. It could be, again, could be PCM, Chevys, whatever it is. Could be the flywheel. Could be anything, right? Could be a wire. Could be this wire that has too much of a voltage drop across it. You would have to measure the voltage across it. Put the positive here, the negative here. But you know what you're doing? Then you have to go under the car and get access to that. I'm going to easy access places. That's why I chose this one. This is easy. Lift up the hood. Go to the fuse box. Go find the relay. Bang. Now, I'm happy I got 12 volts. That told me it's working. I know this part is working. Then I'll be concerned about this part. However, I can jump this. Let's say I want to do it. I want to jump the relay. In theory, which 2 points would you jump in the relay and then tell you which circuit is working? Take a guess. Would I jump this one? Would I jump this one? If you jump this one, by theory, this is 12 volts, and I take a wire across this. Where is this going to? To ground. Not a good idea, right? That's a short to ground. If I jump this, all I'm jumping is a switch. And there's still the resistance in the path of this one. If I jump this, I'm jumping all the resistance. There's no resistance. Whatever these wires will allow that current to flow, that's what's going to flow. If you don't burn the wires, always jump these two. Now, no start. I jump these two. Right? I jump these two. From here to here, I take a jumper wire, jump it, and what happens? This comes on. What does that tell me? That tells me all this part of the circuit is working normally. The problem lies within the computer or this one. Okay? Let's say I jump it again. Nothing happens. As I did for that vehicle, for that customer who said, I changed the battery and it has to be the starter. I can swear to it, it has to be the starter. Another trip to AutoZone, right? And if you're going to bench test it, you want to test that starter when it's on the load, not when it's on a bench. You want to. The best way for me is, or an alternator, I want to take that starter and put it and jump it in the car when it's on the load of a flywheel and a crankshaft, not when it's on a bench test by AutoZone or whatever. You need a load. So again, I go over here. I jumped it from here to here. Did not come on. What could be the problem? Well, now we start like we know the problem is in this part of the circuit. Where do I go first? Guess what? 12 volts. I backtrack. 12 volts here. I go to the other side of the fuse. I have 12 volts. Okay, fine. Then I say, you know what? Let me, instead of going here, let me go over here. Let me go to the battery. The battery has 12 volts. What am I left with? This is 12 volts. This is good. I'm left with this wire and here. Case being this one. This was the problem. The fusible link, which is next to the battery cables, the red one that you see over there, you have a bunch of thin wires over there. They usually loop together. And that one melted. Okay, which is supposed to melt. So here he is saying, let's spend 300, whatever, 200, whatever it is on a new starter, when all you have to do is change the fusible link. How did I come to that conclusion? Jump these two. I said, let me start 12 volts here. 12 volts, 12 volts. I know the fuse is good. Back here, if you want to, 12 volts over here. That means all this is good. Right? But when you go to the other side of the fuse, if this is open, you're going to measure 0 volts here, not 12 volts. Right? So if this is the fusible link, if this is good, you'll measure 12 volts. If this is open, guess what? Which it was. When it was open, 0 volts. 0, 0, 0, 0, 0, 0, 12 volts. Again, if I go over here and I measure 12 volts, I know this is good. If I measure 0 volts, that means this might be open, but I went over here and I measured 0. I went over here and measured 0. I went over here on the other side I measured 0. And over here I measured 12. This is the problem. So this cuts off this. You will have 0 volts here at the relay. So this tells you a lot. This tells you a lot. By measuring this, jumping this and measuring this, if this is 12 volts, all of this is good. The fusible link is good. This is good. The fuse is good. If this is 0 volts, again, could be the fuse, could be this, could be this. Okay, thanks for watching and hope to see you next time.